Have you ever just stopped and wondered what the world is really made of? I don't mean the big stuff like wood or plastic. I mean the absolute most fundamental building blocks of, well, everything. You, me, the entire universe. Today, we're going to zoom all the way in.
No, seriously, take a look around right now. Your desk, the phone in your hand, it all feels so solid, so real, right? But what if I told you it's all just an arrangement of something so small you can't see it, you'll never see it, but it makes up everything you know?
The answer is that everything, and I mean everything, is made of these impossibly tiny building blocks. And we are about to go meet the most important one of them all.
So, what do we call these things? Well, you've probably heard the name before. They're called atoms. And they are definitely the star of our show today. Okay, so that's the official kind of textbook definition. An atom is the smallest possible piece of an element, like gold or oxygen, that is still, gold or oxygen. But let's forget the formal definition for a second. I've got a much better way for you to picture this.
Right. Imagine you have a sheet of gold foil, and you just keep cutting it in half, and in half again, and again over and over. Eventually, you'd get to a point where if you made just one more cut, it wouldn't be gold anymore. That final, tiniest possible piece, that's the atom.
But, the story doesn't actually stop there, because it turns out these fundamental building blocks are built out of even smaller things. So let's zoom in one more time and take a peek inside. For a really long time, scientists thought atoms were probably just these tiny, solid, indivisible little spheres, kind of like super small billiard balls. But it turns out there's a surprisingly complex and beautiful little universe inside each one. It all really breaks down into two main parts. Smack dab in the middle, you have the nucleus. It's this dense little core packed with positively charged protons and neutrons, which have no charge at all. Then, whizzing all around that core is a cloud of tiny, negatively charged electrons. The whole thing is like a chaotic, miniature solar system. Okay, so we keep using the word small, but that word doesn't even begin to do this justice. The scale we're talking about here is, well, it's pretty much impossible to wrap your head around. But you know what? Let's try anyway. And believe me, insanely is not an exaggeration. Prepare yourself for a number that just sounds wrong. That's right, 1 million. Not 1,000, not 10,000. 1 million atoms could fit side by side across the width of one single strand of your hair. I mean, just think about that for a second.
And here's the other part that will absolutely blow your mind. Atoms are mostly nothing. If you blew up an atom to the size of a giant sports stadium, the nucleus, all the protons and neutrons, basically all of the stuff, it would be the size of a single marble sitting on the 50-yard line. The electrons, they'd be like tiny specks of dust floating way up in the nosebleed seats. This means that you, me, this desk, this solid wall, it's all almost entirely empty space. Okay, so if atoms are that tiny and that empty, how on earth do they combine to create the solid, stable world that we see and touch every day? Let's zoom back out a bit.
So what makes one atom different from another? Like, what's the difference between a hydrogen atom and a carbon atom? It's shockingly simple. It's all about the number of protons in the nucleus. That's it. That's its ID card. 1 proton, you've got hydrogen. 6 protons, you get carbon, the basis of all life as we know it. 8, that's oxygen. That one little number changes everything.
But here's the thing. Atoms rarely travel alone. They're social creatures. They love to link up with other atoms, and when they do, they form something new called a molecule.
And this is where the universe gets really interesting. You take 2 hydrogen atoms, you stick them to 1 oxygen atom, and boom, you get a molecule of water. You arrange a bunch of carbon atoms in one pattern, you get the soft graphite in a pencil. You arrange those exact same atoms in a different pattern, and you get a diamond, the hardest substance we know. It's all just atoms, arranged. And what's holding them together? Well, the glue of the universe is something called a chemical bond, and it's all about those little electrons we saw whizzing around. Atoms can either share or completely trade their electrons with each other, and that process creates this powerful connection that holds them together, building everything from a water molecule to you. All right, time for one final fascinating twist in our story. We've been talking about atoms as these ultimate fundamental building blocks. But is that the whole story? See, the name itself, atom, comes from the ancient Greek word atomos, and it literally means uncuttable or indivisible. For thousands of years, that was the core idea, that you just couldn't get any smaller. This was the end of the line. But as it turns out, the ancient Greeks were wrong about that one part.
In the 20th century, we figured out that atoms are not, in fact, indivisible. Through things like nuclear reactions, we can actually split the nucleus, and when we do that, we unleash a truly colossal amount of energy. So atoms are stable, for sure, but they are definitely not unbreakable.
So let's bring it all home. The atom. It is the tiny, invisible builder of our entire reality. It's this strange little world of mostly empty space, but with a core so powerful it can light up our cities and keep our stars burning.
So, the next time you look at the world around you, just remember what you're really seeing. It's not just a collection of objects. It is a spectacular, intricate dance of countless atoms, all arranged in just the right way to create every single thing you have ever known.